All right, so let's take a look at in-class problem number 11. So again, as we're reading the problem, we're looking for units because then that will tell us where to make them in our list, right? Or we're looking for these types of questions. So just things to keep in mind. So in class problem number 11 says a super ball is bounced on the ground and it leaves the ground with a velocity of 19 meters per second. What is the maximum height the ball reaches? Now, there's other questions. For right now, we're just going to pretend like those questions aren't there. I often think a picture is helpful. So we have the ground, we have a ball, the ball goes up, and it reaches this max height. So we have max height. Okay. Now, we know some things about max height, and we'll get to that in a little bit. But that's what's going on right now. So what is in this problem? We have leaves the ground with a velocity of what is the height? So we go through our problem types and we say, is this a 1D motion problem? And the answer is yes, this is a 1D motion problem. Is it in the X or is it in the Y? It's in the Y, so we need to make that list in the Y direction. So we're going to go delta Y, VI, VF, A, and T. And then we can go back to our list. Is it a constant velocity? Does it say anything about that? And the answer is no. It doesn't say anything about constant velocity. It doesn't say anything about acceleration. Therefore, that one isn't true. Okay. Is it a free fall? Is gravity the only force acting on the object? And the answer is, well, let's see. It bounces off the ground and it leaves. We're talking about it while it's moving through the air. So yeah, it's only that one. So because of that, yes, this is a free fall problem. So because of that, we can go through and we can add that to our list. So because of that, we can say that my acceleration is negative g, which is equal to negative 9.8 meters per second squared. Okay, back to our problem types. Does it say the object is a drop or fall? Does it say the object drops or is falls? Super ball is bounced to the ground. Nope, it doesn't say that. So because it doesn't say that, that statement is not true. Super ball is bounced. What is the maximum height? So is it a max height problem? Does it say something about at max height? And the answer is yes, it does. Yes, it does. So therefore, the velocity at max height is 0. So up here, because of that, we can say V is equal to 0. Now, we just got to figure out, is it a VI or a VF? But that's something we can kind of get to. Well, the last thing on here, is it delta Y? Does the object start and end at the same height? And the answer is no. Just for the record, it can't be both. It cannot be both of those. It's either, it could be a max height or it could be a delta Y is equal to 0, but it can't be both of them. So that's all information we can get from the problem type. Then we can go and look at our numbers and we say, hey, the ball leaves the ground with 19 meters per second. Well, that's a velocity, right? Meters per second is a velocity because that's what this tells us. So it's a velocity of some shape and form. So it's 19 meters per second. Now we just need to figure out, is it an initial velocity or final velocity? So because that's the velocity which it's going to leave the ground, we're going to say that's our initial velocity. And if we make the choice to set this up as a max height problem, that is my final location. And because that's my final location, we can say that my final velocity at max height is going to be equal to 0. Now, the question being asked is, what's my height? What's my delta Y? So what equation are we going to use when we don't know time and we don't care about time? We go through and we look at our list of equations. What doesn't have time in it? Equation number 4. So equation number 4, VF squared is equal to VI squared plus 2A times delta Y, not X, Y direction. Okay, so now we're plugging in numbers. My final velocity is 0, so 0 squared is 0. 0 is equal to 19 squared plus 2 times negative 9.8 times delta Y. 19 squared is 361. 2 times negative 9.8 is negative 19.6 times delta y. Now we're going to go through and we're going to subtract 361 from both sides. So we end up with negative 361 is equal to negative 19.6 times delta y. To get delta y by itself, we have to divide by negative 19.6, divide by negative 19.6, and our delta y, our final answer, is going to be negative divided by negative, is going to be positive 18.418. If we round, then we can just say, well, that's going to be 0.2 meters. Okay, so that's how we get our max height. So then for the next part, the idea is we're trying to figure out now we're trying to figure out how long was it in the air. Now we got to think about this. When we say how long is it in the air, how long in the air, are we talking total time from here, from the ground up and back down, or are we just saying from the ground up? Or are we just saying from max height down? How long was it in the air? The idea of how long is it in the air is total time. Now, at this point, this problem is a delta y is equal to 0 problem because it starts on the ground, going up, it reaches max height, but then it's going to come back down and hit in the exact place. This is a delta y is equal to 0 problem. So we have two choices. We could go through and reset up this whole list, but set it up as delta y is equal to 0, and we need to sometimes. But in this particular question, it's saying how long is it in the air? So because we're looking for that time in the air, we can go back to this delta y problem, and we can say, hey, look at this. If we say the total time in the air is 2 times larger than the time to get to max height, I have my list of variables already set up for a max height. If I solve for time here, that can give me my time to max height. And because it's a delta y is equal to 0, all we have to do is double it. So since we have that set up, let's do it that way. So we're going to go through and we're going to say, let's just pretend we don't know delta y and pretend like for a second we didn't just solve for that. Now we did, but let's just pretend, best practice. So we want to go through and we want to pick an equation that doesn't have delta y in it. That's equation number 2. Okay, so equation number 2 is one that we can go through and say VF is equal to VI plus A times T. If my final velocity at max height is 0, then we can go through and say 0 is equal to 19 plus negative 9.8 times our T. Subtract 19 from both sides. Negative 19 is equal to negative 9.8 times T. Divide both sides by negative 9.8 because it's the inverse of the multiplication of negative 9.8 times T. And then our final answer, negative 19 divided by negative 9.8, is 1.939. Now remember, this column is for max height. However, this right here is total time. So because we're looking for total time, this is max height right here. All we have to do, because it's a delta y is equal to 0 problem, is we can multiply it by 2 and we can get an answer of 3.88 seconds for our total time. Okay, that's our total time. Now, this last question is really, it's almost a proof, we could call it. I don't know if it's exactly what we would call a proof, but the idea is we can go and we can do, we've said that if we had said that if you go through and you have a delta y is equal to 0 problem, then I had said my final velocity is equal to the inverse of my initial. So this is really kind of the way that we can prove that, and then from here on out we can just kind of go on and make that assumption, or make that statement, I should say. So it's a delta y is equal to 0 problem, and what we really need to do is we need to go through and we need to make a new list. So it's a delta y is equal to 0. My initial velocity is equal to 19 meters per second because it's still leaving the ground. My final velocity is, I don't know. That's what I'm solving for. And then we can go through and say that my acceleration is equal to negative g, which is equal to negative 9.8. And then my t is equal to 3.88 seconds. And we're using that number from right there. Okay, now that's because this is the total time in the air. Now you said, Mr. Davies, you said it's best practice. Yeah, I did. Sometimes we have to. And in this situation, I guess we don't have to, but it's going to work out probably the best. Okay, so if we go through and say, well, I'm looking for final velocity. I have 4 out of my 5 variables. I really have some choice here. Which one's going to be the best? We can go through and we can say, well, which one of these is going to be the best? I know everything except for I need to make sure my final velocity is in there. So we just got to make sure we don't choose number 3 because we need to have final velocity in there. And really, it's up to you. There's definitely some choices here, but I'm going to say equation number 2. So if we take a look at equation number 2, they're all going to end up with the same. Final velocity is equal to my initial velocity plus a times t. My final velocity is equal to 19 plus negative 9.8 times 3.88. So when we go through and we take negative 9.8 times 3.8, we get a value of negative 38.024. Now, we have to make sure we say 19 minus. So when we go through and we say 19 minus 38.024, we get a final velocity of negative 19.024 meters per second, which is VF is equal to the opposite of VI. And that's where that comes from. So from here on out, that's a safe thing to use. If you have any questions, let me know.